Hello, my name is Jaasim Reyaz, and today I'm going to discuss about my research called Immutable Blockchain, Secured Cross-Domain Data Sharing Using Distributed Ledgers. So, first of all, what is my research about? So, what I'm going to discuss here is the blockchain technology and what are its aspects in terms of security. Also, I'm going to discuss about the current vulnerabilities regarding the cross-domain data sharing between the different organizations and institutions and how the blockchain technology can be used to improve the security of the cross-domain data share. I'm proposing the use of shared distributed ledgers for secure data sharing and transfer over multiple domains. Now, what's the role of cloud in data sharing and what are its disadvantages? Cloud system consists of a centralized model for data storage, which is not very secure in case of the centralized location gets compromised. Being centralized also results in latency since the data transfer uh, from one point to another point may take time depending upon the location of cloud data center. In cloud system, data is generally encrypted before getting outsourced, but corruption of data due to third-party configuration and software bugs is always possible, which leads to the threat in integrity. One of the issues with cloud system is the downtime, which therefore leads to the problem of availability of data. Now, what is blockchain? Blockchain is an immutable, continuous growing list of records known as blocks, which are linked with cryptography in a sequential chain. These blocks are linked together by using hash functions. What are hash functions? These are the functions which take input value and provide an output value which is deterministic to the provided input. Each connected block contains an index, a timestamp, a list of transactions, a proof or confirmation, and a hash function of the previous connected block. Now, what is a distributed ledger? It is a database, in simple terms, containing replicated and shared data, which is independently updated and synchronized at various connected nodes spread across multiple sites or locations. It has a decentralized design, therefore there's no centralized administrator or storage, and since there's no central authority, data is independently constructed and held by each connected node. A P2P network and a consensus algorithm is used for the replication of data. And only after each connected node mutually reaches a consensus, the data is updated on the distributed ledger. Now, what are the advantages of blockchain with aspect of security? So I'm going to discuss how blockchain will secure the data in terms of the CIA model. So first of all, confidentiality. Since all the data is shredded, encrypted, and then stored on the distributed ledger, with only user having permissions to access that data, the confidentiality is maintained. Also, during the transfer of data, there is very less chance that the data can get stolen by a hacker since it's encrypted and shredded while being transferred and stored in the distributed ledgers. Integrity. The immutable nature of blockchain prevents the unauthorized modification or alteration of data, as any attempt to compromise the data at one node would be denied since it does not reach mutual consensus from all the other connected nodes. So therefore, in order to modify the data, a consensus on all the connected nodes need to be maintained. Availability. The decentralized nature of blockchain allows the data to be always available even though any one location is compromised, as the data is located and synchronized in real time over multiple sites or institutions. The data is also readily available with less latency as it can be obtained from any of the nearest connected node, as I had mentioned in the previous slides. Now, coming to the methodology, first of all, the network creation has to be done. And in order to create the network, we need to create the hash functions which connect the blocks to the chain. So in this first step, there will be the installation of Python along with pip and Flask, and all including the libraries. Also, HTTP client like a URL and Postman will be required. In Python shell, representation of blockchain will take place, which includes creation of class whose constructor creates an initial empty list so that the blockchain can get stored. Now coming to transaction to a block. Transaction in a blockchain technology is a record, just like the record which gets stored in MySQL database. Transaction in the form of blocks get stored, and the blocks will form a chain to create a blockchain. Thus, in Python, a transaction list will be created and new transaction will be added in the transaction list. Now coming to power of work algorithm. It's an algorithm in which new blocks are created and mined on the blockchain. The major objective is to discover the number which solves the problem. The core idea between this algorithm is that the number is difficult to find out but very easy to verify. So in Python, we'll be implementing this algorithm for our blockchain. The algorithm's difficulty can be adjusted by modifying the number of leading zeros. Now, blockchain as an API. After creating the creation of blocks and applying the power of work algorithm, the next step includes the usage of Python Flask framework, which is a micro framework and by which the mapping of endpoints to Python's function can be done. Through this, the blockchain can be used over the web by using the HTTPS request. Creating a new transaction to a block will be the initial step, followed by mining of the new block and telling the server about it, and then returning the full blockchain. The server then forms a single node in the blockchain network, which is what is included in the process of Flask setup. Now, consensus. After creating the blockchain which accepts the transaction and allows the mining of the new blocks, a consensus algorithm needs to be created so that which will allow the data to be modified and updated on each node by mutual consensus. Now coming to implementation, this blockchain can be implemented in any infrastructure for cross-domain data transfer. For example, healthcare infrastructure in which the patient data could be transferred over multiple domains, for example, transferred to a health insurance company. And in that way, the data will remain secure as the integrity will be maintained, since the data will be stored in multiple locations in the ledger, and there will be less chances of an attacker to modify the data. Also, privacy is the key here, because every user will have only the user which has the access will be able to access the data or modify the data, and the person having the permissions to access that data will be able to access the certain amount of data. For example, if the data will be transferred to health insurance companies, only that part of the data which is needed by the health insurance company will be accessed by them. And also availability is improved since the data is stored in multiple sites. Therefore, there is always the availability of data, as any issues at one single location will not affect the overall availability of data. So with this, come an end to my presentation. Thank you very much.